Chapter 2, Energy. 2.1, Non-Renewable Energy. So this is an example of non-renewable energy. One of the examples is fossil and nuclear. Non-renewable types of energy can only be used once. There is finite amount of these material on Earth, but they will eventually run out. 95% of the energy on Earth is from non-renewable sources. They are also called non-renewable because the energy cannot be replenished within the short amount of time. 2.1.1 Fossil fuels, which are coal, crude oil, and natural gas. They're considered as non-renewable because they cannot be replenished in a short amount of time. These are called the fossil fuels. These resources come from decomposed dead animals and plants that millions years old. Coal, it is made up from carbon, hydrogen and oxygen, nitrogen, and various amounts of sulfur. The earliest known for coal existed is in China. They are used to extract copper. So the type of coal is formed is lignite, then followed by bituminous coal and anthracite. So the way they rank this coal is by how the heat, the energy produced, and how many carbon change they have. Formation of coal, how they form is when the dead plant matter submerged in some environment, the forces and heat of pressure compress them, and over time the plant matter transform to coal. So when the dead animals buried under the ground, they will be heated and pressurized by the earth and atmosphere, so they will become coal. Crude oil. Crude oil is that viscous slurry of different hydrocarbon other than organic molecules, and trace amount of metal that can be separated and chemically changed into useful fuel lubricants like gasoline, diesel, propane, jet fuel, and even wax. So how crude oil were formed? The aquatic plants and animal died and are buried on the ocean floor. So the layer of sediments are deposited above, and then heat causes the compaction of the remain. See this, the dead animals here? So the remains become oil and gas, which are forced out of porous rock and to form deposit which we drill for. So this is the oil. Before the picture, in the middle picture, they have no oil, and then they have oil. So how crude oil turn into finished product? The crude oil is heated until it boils. The boiling liquid is separated into different liquids and gases in distillation column. These liquids are used to make petrol, paraffin, and diesel fuel. So the crude oil is being processed and heated and in very high temperature, so that the oil that been evaporated will go into this section here. Okay. So natural gas. Natural gas is a mixture of gases which are rich in hydrocarbons. All these gases, methane, nitrogen, carbon dioxide, are naturally found in atmosphere. Natural gas reserves are deep inside the earth near the other solids and liquid hydrocarbons. So natural gas is also under the ground or under the sea with coal and crude oil. Natural gas is not used in its pure form. It is processed and converted into cleaner food for consumption. Many byproducts are extracted while processing of natural gas like propane, ethane, butane, carbon dioxide, nitrogen, which can be further used. Natural gas is mainly used as fuel generating electricity and heat only. But some of natural gas is compressed, is used for fuel for vehicles. It is used as fuel for boilers, air conditioner worldwide. This is used for making fertilizer, also mainly ammonia. So how natural gas were formed? As the diatom died, they fell into the seafloor. They were buried under sediments and other rocks. The rocks squeezed the diatoms and the energy of their bodies could not escape. The carbon eventually turned into oil under great pressure and heat. As the earth changed and folded, pockets where oil and natural gas can be found were formed. So natural gas is not easy one to obtain as the other fossil fuels, because the earth need to have a pocket under the ground.
So now we move on to nuclear power. Nuclear power is an electricity generated by power plants that derive their heat from fission in a nuclear reactor. The nuclear reactions deal with interaction between nuclear atoms, including of nuclear fissions and fusions that deal with matter and energy. Fission is the process of splitting a nucleus into two daughter nuclei leading to energy release, and fusion is the process of two parent nuclei fused into one daughter leading to energy being released. Here, this is a classic example of a fission reaction of uranium-235. A stray neutron strikes an atom of U-235. It absorbs the neutron and becomes an unstable atom. It then undergoes fission. Fission splits a larger atom into two or more smaller ones. These neutrons can strike other U-235 atoms to initiate their fusion. Fusion joins two or more lighter atoms into a larger one, and then it becomes a chain reaction. This is a classic example of a fusion reaction where the deuterium and tritium which is converted to helium and release the energy. Okay, this is the nuclear power plant. How the pressurized water reactor works. The water car is heated by nuclear fission and then pumped into tubes that create steam. The steam then turns electric generator to produce electricity. Next, boiling water reactor. Boiling water reactor produces steam directly into the reactor vessel. Water is pumped up through the reactor car and heated by fission. Pipes then feed steam directly to a turbine to produce electricity. Now, renewable energy. It is an energy that comes from resources which are naturally replenished on human time scale. The example is sunlight, wind, rain, tides, wave, and also geothermal heat. This is the example uses of renewable sources of energy. For example, hydropower, wind power, and ocean energy use electricity. The biomass use heat, electricity, and also vehicle fuel. Solar energy and geothermal energy use heat and also electricity. Okay, these are the importance of renewable energy. First, environmental benefit. It has much lower environmental impact. Second, energy for our children's generation. It will never run out. Third, jobs and economy. Means more jobs are being created. And fourth, energy security. Our nation has increased its dependence on foreign oil supplies after the oil supplies disruptions in 1970. This impacts more than our national policy.
Energy, solar energy. So solar technologies can be characterized into two techniques depending on how they capture, how they convert, and also distribute. These are the two techniques used in solar energy. The first one is passive solar. The second one is active solar. So passive solar, it is include orienting a building to the sun, selecting with favorable thermal mass, and designing spaces that naturally circle air. While the simple example of the active solar is PV panels and solar thermal collectors. What is solar power? It is basically a conversion of the sunlight into electricity. Conversion of energy can be directly using photovoltaic PV, or it can be indirectly using concentrated solar power CSP. Photovoltaic PV. So PV, also known as the solar panels, it captures the sun's energy and converts it into electricity using the photoelectric effect. This is the animated diagram shows how the PV works. So solar panels are usually made of some kinds of semiconductor. Usually we can find is a silicon. So when sunlight or light energy strike the solar panel, electron then knock loose from the atom in the semiconductor material. So if electrical conducts are attached to positive and also negative charge sides, it will form an electrical circuit. Then the electron captured in the form of electricity and becoming a current. Concentrated solar power, CSP. So CSP system use lenses or mirrors and tracking system to focus a large area of sunlight into a small beam. This animated diagram shows how the CSP works. So CSP works when the mirrors in CSP plants focus sunlight into a receiver. So as you can see here, these are the receiver that heats a high temperature fluid. So which is then used to spin a turbine or power an engine. So it then will drive a generator to produce an electricity.
Solar constant refers to the total radiation energy by the sun per unit time per unit area of theoretical surface, in which case it is a sun is a Sofeya. So the magnitude of solar constant is 1366 watt per meter square, or 1.366 kilowatt per meter square. Next is energy loss by absorption and reflection. These are two phenomena that cause the incoming solar energy to be lost in the atmosphere. The first, we have atmospheric absorption. The radiation energy that is being absorbed by the particle is lost to the atmosphere through the long-wave emission of heat energy. And the second one is atmospheric reflection. The insolation of radiation energy is being reflected totally by the particle. This usually occurs when the energy intercepted a cloud or rain particle. Next, we have latitude and tilt. Latitude refers to the horizontal line that is being measured from the equator, and the tilt refers to the angle of Earth rotating. This angle is 23.5 degree. This angle causes Earth to have 4 separate seasons, which is autumn, winter, spring, and summer. Next, we have solar photovoltaic. This, as you can read the various configuration of solar photovoltaic, and this is what it usually contains. Next, we have photovoltaic system. We have two: standalone system and grid-connected system. Standalone system refers to the system itself not being connected to any kind of supply authority power grid because it is already built in with batteries. The grid-connected system, being contrary to standalone system, it is connected to a power supply grid, but don't be mistaken because the system can come with a batteries, but it is rare. Next, we have solar thermal. It is a form of energy and technology used to generate electrical energy or current from solar energy for multiple industrial use. This can be classified into three. The low temperature collectors are being used to heat up a swimming pool. And the second one, medium temperature collectors, are used to heat up also swimming pool, but it is in the context of residential and commercial purpose. And the last one, we have high temperature collectors are used in case of concentrated solar power, which is used to heat up to 300 degrees Celsius, or also used for producing electrical energy.
So what is wind power? Wind power is the conversion of wind energy into a useful form of energy, such as electric energy and kinetic energy, by using a wind turbine. So how does wind turbine use wind energy? So when a high velocity wind hit the blade, will spin due to its aerodynamic force, and the blade is connected to a generator, thus creating electricity. So how the blade spin? When the wind flows across the blade, the air pressure on one side of the blade decreases. The difference in air on this side creates a both lift and drag force. So the force of the lift is stronger than the drag, and this causes the rotor to spin. The advantage using wind turbine: first is zero pollution. There is no harmful gas being released. Second is domestic power source. It is the most efficient source of power besides power plant and solar power. Wind power is cost effective. It can cost much less per kilowatt hour. It can be sustainable for a couple decades with regular maintenance. Types of wind turbine. There are two types of wind turbine. First is horizontal axis. This is the most common wind turbine in modern days. For example, like windmill and wind turbines. It can spin upwind. Vertical axis came with variety of design. For this example is shown as 8-meter style Darius model. That is the shape of vertical axis wind turbine. The blade is omnidirection.
Hydropower is energy generated by water movement. Electrical energy generated by water motion is often called hydroelectric power. Larger hydroelectric stations, which can generate enough electricity for hundreds of thousands of people, usually involve damming a river. Dams are often built high in the mountains where valley sides are steep. Gates in the dam wall can be opened and closed, directing water through pipes that are angled downhill. The moving water in these pipes turn turbines that are attached to massive generators underground.